What's up, Phantom Physics? I'm going to go ahead and show you a few movies here. And first off, we're going to start off with Ralph. He's going to try and throw a ball and try and beat gravity here. He's not going to be too successful. All right, he's throwing it straight up. It's accelerating, but it's actually decelerating because it's changed its velocity until it gets to this point. A little bit more. Right there. Right there, it is at complete rest in this moment of time. As we continue forward, gravity is going to pull it down and accelerate the ball downward. Notice how each second of frame, it travels a farther and farther distance. That is the definition of acceleration. Until finally we hit the ground. Kaboom! All right, here is Tori and Sky. They are just gently throwing the ball until I slow it down. And now what we're looking at is we are going to see interaction of a tiny bit of lobbing going on here. Now, let's go ahead and take a look at that again. As Tori throws the ball, there is gravity acting upon it, so that's why it slows down until it gets to this point right there. It is at a complete rest at vertical means, meaning it's still going back and forth, it just isn't going up anymore. And then, of course, gravity brings it back down to Earth, and it accelerates downwards at 9.8 meters per second squared. All right, let's go ahead and see here. This is Tori and Sky. They are both dropping different objects, and Newton tells us that all objects tend to fall at the same rate, or they accelerate downwards towards Earth at the same rate. What we're going to see here is that that's not always the case in an atmosphere full of air. As you can see, the ball has reached the ground much faster than the fuzzy dice, the big soft fuzzy dice. That's not a coincidence. There is a reason for that. There is air resistance. Air resistance is what's causing the dice to slow down. To drastically show this, Ralph and Tori are dropping two different things, the ball and a giant inflatable ant. The ant is already losing. Okay, as the ball gets closer to the floor, right here, boom, it's already beaten the ant by over half its distance. Now, check out the ant. The ant is an oblong shape, meaning it resists passing through air, meaning it reaches what is called terminal velocity. Terminal velocity. That is example one, terminal velocity, and eventually falls on the floor. All right, so here's the extreme example. This is example number two. Write this down. Sky and Raphael are dropping two different objects, obviously of different shape. The ball will fall normally, or should I say with the acceleration of gravity. The copy feature or the copy filter will immediately reach terminal velocity based on its shape and mass. And there is no comparison. Boop. Copy filter kind of flutters the ground. Alright, well, I guess it kind of showed up anyways. The death metal illegible band name of the week is Leviathan. Leviathan. Alright, see you in class.